Alright, welcome. This is a 10.5 video, and so we're going to just do 3 problems in this video. That's the goal right here. And so our first problem, we're still finding area, and we're still dealing with regular polygons. We're going to have to use a different technique that we have right here. So I'm going to let the computer just kind of draw these out really quick. So let's have you guys draw this nonagon out right here. And again, we have the center of that circle, we'll label it as C, and each side is going to be 10. So let's see, we draw a triangle. Obviously, we have the 2 radius. The radius are both the same, so it creates an isosceles triangle. And we have a nonagon, so we know that each side is going to be 40 degrees. And we have an apothegm. Remember, our apothegm goes from the center and creates a right angle with the side, and it also bisects the angle and it bisects the side. So we dealt with that in our last lesson that we have right here. And if we are trying to figure out what half of that angle is, what we are going to do is we're going to take half of 40, and that's going to give us 20 degrees that we have right here. So I want you to not only have this picture down right here, but let's just write central angle, and that would be 360 divided by 9 is 40. So like on each of these right here, each of these would be 40 degrees, just like what we did in our previous lesson. And then perimeter, if each side is 9, and if each side is 10 and there are 9 sides, then my perimeter is going to be 90. Have that end that we have right there. And then from this one, we are going to draw a right triangle. So we have this right triangle, and we see that we have this degree up here is 20. And again, remember, this side got cut in half. So if the whole side is 10, it got cut in half, it's not going to be 5 that we have right here. Okay, so the ones that we dealt with before were all special right triangles. A 30, 60, 90, a 45, 45, 90 degree triangle. This has a 20 degree triangle. So we can't use special right triangles, but it's still a right triangle, and we have an angle on the side, so we can use our SOHCAHTOA. We can use our trig function in order to solve for this side. So we need to figure out what the apothegm is, and the apothegm is this straight line. That's what we're trying to figure out right there, and so this is going to be x. And so if I am starting at this angle, remember I start the angle when I'm doing my trig functions, and this 5 right here would be opposite, the x would be adjacent, so I'm using my tangent. So I have the tan of 20 is going to equal, the opposite side is 5, and the adjacent side is x. And so now I just need to get this x to be all by itself. I got to get it out of the denominator, so I'm going to multiply both sides by x. And so I get x times the tangent of 20 is going to equal 5. And then to get the x all by itself, I'm going to divide both sides by tangent 20. So in my calculator, I'm going to put in this right here in my calculator, which is 5 divided by tangent 20, and that's going to give me a decimal, and so we're going to get x is going to equal 13.737, and we'll round up to the 4. So the more numbers that I use right here, the more accurate I'm going to be. Okay. So I'm going to kind of put this off to the side right here. Use a different color. So we know that what we just found right there was the apothegm. So we know that, and let's label this right here, we know that the apothegm is 13.7374. And we know that the perimeter, which is what we found earlier, if each side is 10 and there's 9 sides, my perimeter is going to be 90. Well, my formula is apothegm times the perimeter, and I can either multiply it by 1/2 or just divide it by 2. So I get 13, I get that times 90, and then I'm going to take that and divide it by 2. So my area for this nonagon is going to be 600, and I get 618.18, and we'll just label this, we're talking in square centimeters, and it's area, so we got to make sure that we square those centimeters. Again, I need to find the apothem, I need to find the perimeter, and once I have those two, then I can solve for that. And on these types of problems, we're going to be having to use our trig functions. Okay. Alright, my second problem that I have right here is we are going to try and find the area of this pentagon. So we're told that a regular pentagon has each side is 4 inches, so each side is going to be 4 inches. And so the first thing that we're going to do is we're going to draw our the center of that polygon is right here. And again, we know that we have a radius that goes out to each of these sides that we have right here. Really poorly drawn right here. And we know that all these angles added together are going to equal 360 degrees. And it's a pentagon, so there is going to be 1, 2, 3, 4, 5. There are 5 different sides that we have right here. So each of these angles, 360 divided by 5, is going to give me 72 degrees. So if I write these right here, each of these are going to be 72. Okay, but we have an apothem. So this apothem comes right here, and I know my lines are really off, but we have the apothem cuts this 72 right here, cuts the angle in half. So we get 72 divided by 2, which means that each of these angles is going to be 36. And not only cuts the angles in half, but it also cuts these sides in half. So if the whole side is 4, it just means that this side right here is going to be 2. So we just created a right triangle, as sloppily as that is. But our right triangle is going to look something like this. And we said this side is 2. We said this angle up here is 36. And we are trying to figure out what x is. So again, we see this is not a special right triangle, so we can't use our 30, 60, 90, and we know can't use it. We have an angle, we don't have all sides, so we can't use our Pythagorean theorem, so we're going to have to use our trig functions. And again, we are always going to start from the angle, and this is opposite over adjacent, so we're going to use tangent again. So it's going to be the tangent of whatever the angle was, which in this case it's 36, is going to equal the opposite is 2 over the adjacent is x. So we need to get that x out of the denominator, so I multiply both sides by x. So we're going to get x times tangent 36 equals 2. Divide both sides by tangent, or divide both sides by tangent 36, so that way we're just left with x. And our apothem right here is going to equal 2 divided by tangent 36 is going to give me approximately 2.752, and we'll round it up to 8 that we have right there. Okay, so this is my apothem that I have. Okay, my perimeter, so this is apothem. And let's put down here, my perimeter is, if each side is going to be 4, and it's a pentagon, which means that there are 5 different sides, means my perimeter is going to equal 20. So let's switch this to blue. My final answer is going to be, this is my apothem, which is 2.7528 times my perimeter, which is 20, divided by 2, or times 1/2, times 20 divided by 2, and we are going to get an area of 27 point, round your answers to the nearest square inch, so if we're round to the nearest square inch, then I have 27.5, which we're going to round this up to this here, and so this is going to be 28 square inches. So just got it. Again, it's just rounding right here, but I got 27.527, but I round that up because I want to know to the nearest square inch, and so that's 28 square inches. Alright, and then our last problem that we have right here. So this one says we have a stop sign, it's a regular octagon, and we are given the radius. So the radius is going to be 6.2, and we need to find the area. So again, we need to find the area, we need to know the apothem, and we need to know perimeter. And we are given neither. And we aren't even given a side that we have here. So we're going to do the same thing. Again, we got to figure out if each of these angles that we have right here from the center, what is our central angle? What is this angle going to be? Well, we know that all of them added together are going to be 360, and we have an octagon is 8 different sides, so we're going to divide by 8. So 360 divided by 8, which means that each of these angles is going to be 45 degrees. But again, we have this one angle right here is 45, but we are cutting that in half because we have the apothem cuts in half. So this is now going to be 22.5. So let's draw my triangle. I have a right triangle. And again, we need to figure out what the perimeter is and what the apothem is. We have a right angle. We know that this up here is 22.5, and we were given the radius, which is 16.2. So we just got to think, okay, well, obviously we know that we can use our trig functions, our SOHCAHTOA. We can use our SOHCAHTOA right here, because this is not a special right triangle. And I got to think, well, what am I trying to solve for? Well, first thing is, if I solve for this side, that perpendicular, that straight up and down, that's my apothem. And that's what we definitely want to know that. So if we are solving for this right here, let's call this x. Oh, that's bad. Let's call this, let's see if I can do it right. X. Yeah, there we go. If I call that x, well, if I'm going from this angle right here, this is going to be adjacent, this is going to be hypotenuse, so I'm going to use the cosine of 22.5. And this is going to equal my adjacent is x, and my hypotenuse is 16.2. So I'm going to multiply both sides. I'm going to try and get this x to be all by itself. Multiply both sides by 16.2. These are going to cross off and just leave me with x. And I'm going to plug this right here, 16.2 times cosine 22.5. And this is going to give me 14.9668. Let's call that. Okay, so that right there, what we just found, that straight up and down line, that is going to be my apothem. So we'll write it over here to the right. Apothem equals 14.9668. And again, the more that numbers that we have, the more accurate, the more precise it's going to be. Okay, so make sure that you guys have this written down. I'm going to erase this really quick to give myself a little bit more room. Okay, and so the second thing that we got to find, we have apothem, we got to find out what the perimeter is. And so to find the perimeter, again, all we know so far is we have our right triangle, and we know this is 16.2, and we want to find out what this side is. Because if we can figure out that whole side, that's going to be my one side, and if I know all of 8 different sides, I can figure out what that is. So again, we know that this right up here is 22.5, and this time we're going to try and figure out what this side is over here. So if I'm starting from the angle, this right here is going to be opposite over hypotenuse, so I'm going to use my sine. So I have a sine of 22.5 is going to equal the opposite is going to be x. My hypotenuse is going to be 16.2. So to get the x to be all by itself, I multiply both sides by 16.2. And so I get 16.2 times sine 22.5. And this is going to give me one side, x right here is going to equal 6.314. Okay, so that's what this side right here, 6.314. But again, remember that the apothem, it cut it in half, right? So that's only half the side. So if I want to know what the full side is, I have to take this number and I have to double it because there's two of them, right? So I got to double it, so because if I only know half the side, when I times this by 2, I'm going to get that full side, which means that x is going to equal 12.6, and let's just round this to 29. Okay, so that's what one side is. So this whole side right here, and let's write it up here so it can be a little more clear, is 12.629. That's what this one side is right here. So we want to find the perimeter. Well, how do we find perimeter? Well, if there are 8 different sides and each side is that, we are going to do 12.629 times 8. And this is going to give us, times 8, is going to give us a perimeter of 101.03. So we get a perimeter right here of 101.03. And so now if I have those two things, apothem and I have perimeter, I'm just multiplying these two together. So my final answer, put it in blue right here, 14.9668 times 101.03. Multiply those two together and then divide it by 2. So I multiply by 14.9668, and then I cut it in half, and I'm going to get an area right here of 756.0. What am I rounding to? I got 0.4, but it told me to actually round to the nearest square inch. So since it's 0.0, we're just going to leave it just like that. And again, we've got to make sure we label it correctly. We are talking in inches, so I have to have squared inches. This is square inches. And that right there is my final answer. Box it in. Boom. We did it. Alright, so we'll do some more practice. Practice makes perfect problems. Okay, see you guys soon.